To start off the course, I wanted to give everyone just a little perspective. It's not directly related to the mind, brain, or machines, but I think it's good to remind everyone who studies science in general just how new the human experience is. Things pop up and evolve at a rapid pace, and it's good sometimes just to take a step back and look at the magnitude of life and Earth in general. So, here's just a quick overview or history of how we got here. So the timescale of evolution is seriously huge. I mean, have you ever wondered how long it actually took us to get here? It's a little difficult to understand, so let's use an example. Earth was formed around 4.54 billion years ago. Humans have a hard time understanding how big a billion of anything is. It's in our lives all the time now, whether we're talking about government budgets, Earth's population, or the riches of Jeff Bezos, Warren Buffett, and Bill Gates. But do we really grasp how large that is? Okay, my example is this. If I were to ask you how long ago 1 million seconds was, what would be your guess? 1 million seconds was about 12 days ago, so almost 2 weeks. But now if I asked you how long ago was 1 billion seconds, what would your answer be? 1 billion seconds ago was almost 32 years ago. So we went from 12 days to 32 years, and that difference between millions and billions is just absolutely huge. And we'll come across these terms, billions, in neuroscience. For instance, the human brain has about 86 billion neurons. So just that term is just super hard to understand. So with that in mind, let's look at our timeline. I have here listed the numbers for you to take notes on later, but I find it better to use an example. I'm drawing this example heavily from a book that I'll recommend later, but I think it's a really neat example to understand kind of what scientists call deep time. So let's pretend we're taking a trip to the moon. The moon is 236,795 miles from Earth. It typically takes astronauts about 3 days to make this trip. So at the start of the journey, 4.54 billion years ago, Earth is formed. It's just a big molten ball of fiery lava at this point. So about 38 minutes into our 3-day trip, the moon forms. We move further along, and then next about half a day into our 3-day trip, the Earth cools enough and enough rainwater collects to form the oceans. A long time after that, now only about 16 and a half hours into our trip, we see the first signs of life, blue-green bacteria. In real time, this is about 3.5 billion years ago. Okay, so fast forwarding tremendously now. Dinosaurs are kind of the relative latecomers here. We're pretty close to the moon, about 2 days and 20 hours into our 3-day trip, so almost there. We shut our eyes for a nap, and about 3 hours later, the dinosaurs are extinct. Now we're almost there, about 7.5 minutes away, and we're prepping our landing gear on our astronaut trip, and we're seeing the earliest human relatives. Homo sapiens, as we know them today, come in about 15 miles from the moon's surface, a mere 17 seconds away from landing. Now we're 67 feet from the surface of the moon with less than a second to go, and the United States as a nation comes to be. The modern field of cognitive neuroscience is born when we're about 12 and a half feet away, and you come as a student into existence with about 5 feet to go. Not even enough distance to socially distance ourselves from the moon, and all from a starting distance of 236,795 miles. So all of human history itself is just from that very last leg of the trip. The point I want to make here is that all of our human understanding and our knowledge, and the knowledge we'll discuss this semester, is just a cosmic blink. That's our history on how we are able to learn about brains today, and I just hope at the very least it gives you some perspective. So really quickly, this book I mentioned earlier, I recommend reading Bill Nye's book Undeniable. It's just a fantastic book by our childhood scientist hero, and just a good book for a lazy Sunday.